So for linear equations, this is bringing it all the way back to Algebra 1. So on example 67, I am going to first simplify each side of my equal sign. If you like, I've seen some people draw the line where the equal sign is. You do not have to do that, but some people maybe like drawing the line. I don't know. Totally up to you. It just kind of helps show you the left and the right side of your equation. So on the left side, I've got 39 minus 5k. It's simplified. You can't do anything with that. On the right side, though, what can I do? Yeah, I can distribute this -8 and multiply. So -8 times -8 is?
Positive
64. And -8 times -k? Plus 8k.
Why did you not make that -7? And then
Order of operations says I have to multiply before I add. Yep. That's a common mistake.
Yeah.
Have you seen those arguments on Facebook? Order of operation arguments?
Yes.
You know?
I have not on Facebook,
Yeah.
but not on Facebook.
Not on Facebook, Instagram? I don't know. All right. After I distribute the -8, then I'm going to combine like terms. What can I combine? 164. So I get 65 plus 8k. And I'm going to drop down the 39 minus 5k. And my equal sign is in between both of those guys. All right, so once you have simplified both sides of your equal sign, then we have to move a letter. Move your letters before you start messing with your numbers. All right, we want to get our k's on the same side. So right now I have a -5k over here and an 8k over here. Before I start moving numbers, I want to get my k's together. Which one do you want to move?
-5.
Yeah, I'd move the -5 just so I can get rid of the negative, but it really doesn't matter. Some people like always moving and keeping them on the left, but you know, to each their own. All right, so over there we're going to cancel, and I'm going to drop down the 39. And I've got 65 plus 13k. All right, so once you move your letters together, then we can start solving for k and getting k by itself. So I'm going to minus 65, which I think is going to give me -26. And then what? Divide by 13. So -2. All right, so that's my first example. For example 68, the first thing I see that I don't like is my fraction. So I'm dividing by -7. What would be the opposite of that?
Multiplying.
Multiplying. So I'm going to get rid of that by multiplying by -7. And if I do it to one side, got to do it to the other. All right, so on the left side, what happens with these -7s? They cancel, and I'm left with 4y minus 7. Over here, I'm going to distribute my -7. So I get -7 plus 42y. All right, so after you simplify both sides of your equal sign, your next step is to move your letters. Which one do you want to move? I'd probably move the 4. Try to stay away from negatives as much as possible. So minus 4y minus 4y. So -7 is -7 plus, what is that, 38? All right, now I can move my numbers. So what do I do next? Add 7. So over here, I'm just left with 38y. What's left on the left side? 0. Is that okay?
Yes.
Yes, 0 is a number. It is okay. How would I solve for y? Divide by 38. And so y is going to be 0. All right, and my last example. All right, I've got a lot of stuff going on here, so I'm going to simplify both sides of my equal sign. So if I look at the left side of my equal sign, what can I combine? The x's. What's 3x and negative x make? 2x. And then I'm going to do the right side. So I've got to multiply. All right, 3 times 4 is 12 divided by 6, which is 2. Plus, all right, 3 times 12 divided by 2, 18. And then I also have a plus 7. And so when you combine the 18 and the 7, 25. And I'm just going to drop down that 2x plus 11 from this other side. All right, after you simplify both of your sides, we want to get our letters together. So what happens when I move my 2x?
0.
Yeah, you get 0 and they both cancel. So what are you left with on the left side?
0.
11. But yeah, 0 plus 11. And then on the right side, 25. Does 11 equal 25?
No.
No. So your answer would be no solution. Do you know the symbol for no solution?
Circle with a line through it.
Yes. I'm okay with either one. You can either write the whole thing or you can do the symbol with the line through it. All right. So what we're going to do now...
I'm sorry.
What's up? Oh, are you checking?
No, I need to ask you something.
Okay, well, I'm about to have them work on stuff, so perfect timing. If I can figure out how to
My
get...
brain's about to explode. I think I know the answer, but I think I don't. I'm into my guessing.
All right, so what I'm going to do right now is I'm going to give you some time. I don't know if you'll finish or not. I might give you like 5-ish minutes to work on the first part of your homework. The first 6 questions are all linear. And then we'll do literals. There are a lot of people in here. You have got to keep the noise level down, okay? So if you're talking to someone, that's fine, but you can whisper to them.
There's a ton of people in this class.
There's 27. It's a lot.
Is it does not exist? Because I don't know how to factor that in. There's a 2 on the end, so I thought I could do quadratic, and I can't do a quadratic because it's a squared.
Okay.
And
No.
then I can't factor anything out because it's not a.
It's a trinomial. What multiplies to give you a squared, but adds to give you negative 2a.
Wait, what? But there's no a here.
No, but it's okay. Think of it as like x squared minus 4x plus 4.
Yeah, I would think it like that, but then there's a square. That's what I'm saying. Squared doesn't make sense. I thought it would be like a quadratic where you could split it up, but you can't because it's a squared.
I'm already done.
I've never had one where there's squared on the front and on the back.
It's like with letters. So think
I
about,
think it's just because it's weird.
it is weird. Think about what 2 numbers will multiply to give you a. Squared. Well, what'll give you a squared? A times a, right? What's a plus a?
2a.
2a. So x and x, a and a. Because a times a is a squared.
Okay,
A
so it's
plus
just minus.
a.
It's just
Yes.
subtract. Okay, and then you can take one of those out.
Right.
And then it's just x
That's what I got.
0. Oh my gosh, my brain hurts. I was just sitting there and I looked at it and I was like, and I had to ask Mr. Saunders to make sure it was 0 because I was like, wait,
Did he know how to do it?
Yes, he did.
He did?
Well, I was just making sure that it was 0 on top. And he was like, yeah, that's 0 on top.
Is it fine if we get a fraction?
Yes, you do get weird fractions.
Oh, you do get weird fractions?
Yeah, you do get weird fractions. I'm okay with fractions or decimals.
So I can put like for that one, the decimal part of it.
Okay, so it's supposed to be.
I got 3 wrong.
It's so bad.
Just fun.
You know the thing that Krishan does?
But it ends in a set.
That's what he does?
Yeah, Krishan's like addicted to this. He can't stop.
I hear him in the Jackson. I'll hear him in the back.
Yeah, he'll go. He'll go. Yeah, I don't know what you're talking about.
Like in the middle of the, before I snap the ball, he's just going. I noticed that.
You sound
Oh,
it's like you get your tongue over through your mouth and you say. That sounds so weird. Why are you laughing?
you just laughed too. Yeah,
No, I
you
didn't.
laughed
What
as
are
you
you
said
talking
that.
about?
Where's my
Oh, because we just simplified it. Instead of like getting an answer, we just simplified it. It's like the fraction.
Yeah.
What's the? I don't know what I'm doing.
Little mistakes. Little mistakes. Okay. Thank you, Miss Small.
Yeah.
Joseph, I need my thing back. You want on TikTok?
For 4, 10 over 26, yes. I'm going over.
Isaac,
Yeah.
did you get -2 when you get
No, I wrote it down like that.
Oh, I have your paper.
Did you get it from?
I wasn't trying to do that, I was like,
What are you doing? No, I didn't. You're right. What are you doing?
Wait,
The 5 on the Yeah, you would divide by 26. Right, and that 26 is gonna be on the bottom.
Oh, I didn't. How long can you do?
Oh, he's right.
Negative 5.
You look stupid. Stop, Weston. Oh my gosh. Great.
What do you say? 7 over 5? Oh, yeah. I know you have it. Joe, is Joe Who had it?
Yeah. Wait, no, I lied. Sorry.
And you're going number 5 then?
And I'm doing it right now.
Yeah, what?
4
Yeah,
times
I mean,
5
yeah.
divided by 3.
Your weird fraction.
What's the first one? 16.
Weston. Wait, how do I get rid of this?
what are you doing?
Weston.
I thought so, but I couldn't remember them were so far back.
Yeah, it was positive.
Yeah, I got you.
Did you actually stuff my paper on that? Okay, put it on video and then
What are y'all doing?
Really, what did you get for 5?
I did 6 and I just got.
That's freaking gay, Joseph.
What's 7 times 8? No. 16. I did 48.
Like.
Well, if you took my paper, then what's blue or five? Oh, that's weird. That's weird, Joseph. What's that? Is it my paper?
Really?
What you doing?
I have no
What?
idea where it went.
Negative 1/3 equals X.
1/3.
That's really wrong, huh?
That's not what I got.
Get your
You did have it all along.
Negative 36X.
If I get you a calculator when you stop.
18 minus 6X.
Do you want on video on this one?
Plus,
That's
plus
32.
30. That's 32.
Alright, you tell me 4.
Listen, I can just caught you.
Never mind, Bryce.
But I got 56.
What does that become?
Yeah.
This one is
even
like.
Six is not equal to 96. Sorry, what?
Now you did it.
Is it still 10?
And I'm not getting your
Because
I
it's
just
really
did it all
weird
in one
fraction.
step.
Chicken
I'm not
said.
getting your freaking
Your fraction's a lot nicer than my fraction.
You said if I got you on, you would stop doing that.
All right, I'm gonna give you like a minute to finish up the problem you're on, and then we're gonna move on.
For negative 5 over 13.
Yes. A minute.
Just answer number 2.
Yes. I mean, I normally have my answers in fractions, but you can put them on if you want. But if you ever look at the keys, they're probably in fractions. Yeah.
Okay, did you get it right?
Okay, pause where you're at. We are gonna keep going here on the notes. And we have to talk about literal equations. We're gonna have 2 more sections. We have literal equations and absolutes, so we have to keep going. All right, a literal equation. Are equations that contain 2 or more variables. So all the equations that you just solved probably just had x or some other letter, just one of them. Now we're going to have x and y and z and h and j and k and all other kinds of letters. And so to solve for one of the letters, we just want to rearrange the formula. You don't do as much math. You're not going to do as much adding and subtracting. We're going to do rearranging. All right, so over here on this first example, I want to solve for j. And currently, j is in the bottom of my fraction. And I don't like it in the bottom of my fraction because I want it to be up top. So what do I need to do to... Yes, thank you. So we're going to multiply by 3j. And if you do it to one side of your equation, do it to the other. So that's going to get the 3j out of the bottom of that one side, and you'll just be left with 8h. On the other side, we can multiply the 3 and the 6 together and get 18. The k and the j are just next to each other. Now remember, the whole goal is to get j by itself. So what do I do next? Divide by 18k. So j is going to be 8h over 18k, which reduces to 4h over 9k. Because 18 and 8, they're both divisible by 2. Is that okay? All right, so on 71, we are solving for y, and y is right here. So I want to move all that other stuff away from the y. What do I move first? Yes, subtract the 3x. So 7z minus 3x. All right, now, do I want to divide by 4 or square root? So when you are solving, the order you do things is reverse PEMDAS. Reverse PEMDAS. So first you add or subtract, then you multiply, divide, then you take care of your exponents. So we are going to divide first. And once again, we're not really doing math. We're just writing that as 7z minus 3x over 4. You're just rearranging. So you don't have to actually do any simplifying or anything. You're just moving stuff and rearranging. And how do you get rid of a square? Square root. And every time you square root, there's a symbol you have to put in the front. Yes. Okay, and then my last example of these guys is we are solving for p, and 2 terms have p. So what I'm going to do here is I'm going to get all of my p's on one side. So I've got PR, and I'm going to minus 2p. I still got the minus n, and then technically 0 over there.
Divide by r.
Not yet. So everything that has a P we want on the left. If it doesn't have a P, we want to move it to the right. So what do we want to move to the right? The M, yep. So I got PR minus 2P equals M. Because we add the M over here. All right. So now after you do that, so this happens when you have lots of variable, like if you have a lot of x's and we want to solve for x, this is kind of the method you use. So this one here, I had two terms that had the P and I moved them to one side. Everything on the left now should have a what? A P. So we can take a P out. Because it's a GCF. So we can pull a P out of both of these guys and we're left with R minus 2. Does that make sense?
Yep.
Okay. So that's why we move everything with a P on the left, everything without a P on the right, so we can pull a GCF out. And then what would be the last step for getting P by itself? Divide by R minus 2. Because right now P is multiplying by R minus 2. And so the opposite of that would be dividing. And once again, we're not actually doing a lot of math. It's just a lot of rearranging. So rearranging of all the stuff. Okay. I'm going to give you 5 minutes exactly. So at 48, I'm going to move on. You've got 4 questions. You've got 2 on the front and there are 2 on the back.
When do we leave this?
Do what?
When do we leave this?
301.
So, would you subtract the x or would you divide it?
Start by
But it,
Because we want to solve for R. First, I would multiply by, oh, you did the 360. Yeah, then just divide.
okay.
So divide by anything that you don't want.
Would you start by?
Wait, you divide by it?
Yeah, I would. I would multiply by
I thought you
360,
would
get that guy over the other side.
Can you do 2 pi? Can you do that like?
That's the first step, so we don't like the fraction. So now by
But
360.
it's a triple division.
Yep.
What is triple division?
I don't even know, bro. I've already divided by one thing. How many are you supposed to divide again?
I don't think you're supposed to
You
divide
just
by
divide it all in one
I
shot.
asked her.
Yeah, so the 2 pi R all goes on the bottom.
Wait, but you're solving for all.
Yeah, so the.
Oh, we're solving for R. I'm sorry, x2 pi. x2 pi. Yeah.
So,
Is that, yeah.
Wait, would it be 2?
would it just be R equals
pi
360?
x?
How does that work?
I don't think it matters.
So R equals 360 out by 2.
It's just a weird
No, you
rearranging.
That felt like how?
Extra high, because that's
360
what
L, not minus x.
Wait, so
Because
360
it's all being
L.
multiplied.
R equals
Divided by x
2
2
pi.
pi
Yeah, so we're just
equals
gonna
R.
put that over here.
Or is it pi 2x or 2 pi?
It's x 2 pi. Wait, it's x 2
R
pi.
equals 360 L over x.
Or what did, hold on one second.
No.
It is, but
Yeah.
it just said that.
Hey, it's x 2 pi.
Yes, we said
So
it.
it's all of this.
Well, you were saying 2x pi, so.
X 2 pi. That's what I wrote down.
The 2 pi.
Divide by 3 first.
Divide by R.
Over 1. So 360.
No, I mean just mine.
Subtract 2 Boom.
Yeah.
Oh, I kinda like this.
But x tends to
What's
Yes, you'll do. This is a different color. RS. And then, yeah, and then you multiply by 3. So I'm taking R right there. REC.
You divide all that by
Equals A squared.
That's part of it, but now you gotta separate it.
Hey, Jackson, what do you like?
Hold on. I'm writing. That was so good.
What happened in
-4.
You multiply both the whole.
Did you see me?
Stop.
Plus or minus?
Although, that's minus, right?
Yeah, that's right.
I mean, it could, maybe.
Thanks, bro. Appreciate it.
This is the one that has all the R's.
Number 9.
So you want to get all the R on the left side.
Are you?
And then taking an R out, kind of like we did.
Curly.
All right, I got to do the last part of the notes here to make sure I can get through it. I will still take questions tomorrow before your homework quiz. So if you have a question or something, I'll take them tomorrow. All right, so the last thing that we had to talk about solving here is absolute values. So hopefully you remember solving absolute value equations last year in Algebra 2. You had a whole unit on absolute values. I know you did. Tell me, what does an absolute value sign do? Makes everything positive. Very good. So because the absolute value makes everything positive, we have to account for that. So when you get, like on example 73, when you get your absolute value bars, you have to split this up into two different equations. The first equation, you're going to leave the exact same way, but without the bars. The -2 minus 10x equals 98. The other equation, you are going to change 98 to be negative. Inside the bars stays the exact same. And so we are going to solve both of these guys out. So I'm going to add 2, which is going to give me 100. And divide by -10. And so one of my answers is going to be -10. And we're going to do the same thing for my other side, the blue side. We're going to add 2. But -98 plus 2 is going to be -96. And then we're going to divide by -10, which is going to give me a funny fraction. It's going to give me 48 over 5. And so you have 2 answers. Is that coming back? Do y'all remember doing absolute values? Okay. So drop down to 75. Straight down. If there is stuff outside of your absolute values, right? So right now this is my absolute value sign, and I've got a 2 and a -9 outside. I need to get rid of that first before you split your equation up. We do not like having stuff outside. So what am I going to do first? Add 9, which is going to give me -34. 2, 6 plus 8x. And then what? Divide by 2. You can't distribute it. We're going to divide. Sometimes if you distribute, you will end up with the same answer, and it's going to be okay, but technically you're not allowed to because they're not parentheses. But we can divide by it. Okay, so from here is where normally I would split this up, right? But something's happening. Does anybody see it?
There's a -9.
A negative what?
I'm sorry, -9.
Not the negative. No, we added the 9 and we divided by the 2. Something with a negative, though. -17. And I asked you in the very, very beginning of this, will my absolute value ever be a negative number?
No.
No, because what will the absolute value sign do?
Very positive.
Turn it positive. So right here, since this is negative, your absolute value is equaling a negative number, we don't even have to do all this other stuff. What can we say the answer is?
No solution.
No solution. So watch out for those negatives. If the absolute value ever equals a negative number, you can just stop and say no solution. All right, it can never be negative. All right, so let's talk about 74. And this will probably be my last one. So on 74, I've got the 6x minus 7. What do I need to move? The 5. All right, so I've got two things over here. I have 3x plus 5. When you have two things over there, don't worry about whether they're negative or not. You have to solve the whole thing out. All right, so we're going to split this up. The first way, you're going to write it the exact same way. 6x minus 7 equals 3x plus 5. The second way, I'm going to keep the 6x minus 7 the same, but the 3x is going to what? Negative, and the 5 will be? Negative. So everything on the right side is going to have to switch signs. All right, and now we're going to solve. So I'm going to minus 3x. 3x minus 7 equals 5. Add 7, which is going to give you 12. And divide by 3, which is going to give you 4. Then we're going to do the same thing over the other side. We're going to add 3x, which is going to give you 9x. We're going to add 7 to the negative 5, which is going to give you 2. And then we're going to divide by 9, which is going to give you 2 over 9. Okay, we're not done yet. Hold on. Because when you have two numbers over here on the right side, we have to check our answers. Do you remember checking for extraneous solutions? Yes. Okay, so there's a quick way that we can check. For extraneous solutions, all I care about is this guy right here. I care about what the absolute value equals. And I need to make sure that what the absolute value equals is not going to be negative. That's all that matters. So when I plug 4 into the thing I highlighted, what the absolute value equals, 3 times 4 plus 5.
17.
Is that negative or positive?
Positive.
Positive. So will 4 work?
Yes.
Yes, as long as it's not negative, it's good. When I plug in 2 over 9, let's say you're not even good with fractions, but would that be a positive or negative? Positive, because you get a positive times a positive, which is a positive, plus another positive, it's still positive. So you don't even need to know the number, I just need to know if it's positive or negative. Since that's positive, that one will also work. So when you have two things over here, like an x and a number, make sure you check for extraneous solutions. Does that make sense?
Yes.
Okay, do you want me to do the other one,
No.
or do you want me to let you work?
Work.
Okay,
How would you do number 10?
on the homework?
The source of information. I would like question. What?
Okay, so I'm going to put, so everything with an R needs to come on the left side. Does that make sense? And so now everything on the left has an R, which is what you want to solve for. So I'm going to pull an R out, which that's going to turn into a 1. That's going to turn into an S. That's going to turn into 2S.
So you don't add like when you do that.
Oh, I guess I could. I could add these guys, right? 1 minus, because you did that, which is fine. And then you would just divide.
Yeah, I'm telling you, I'm the one that things always get twisted up.
Does that make sense?
Look at that.